For the network shown in the figure, determine A part Re, B part Zi, that is your input impedance with R0 is equal to infinity. Then Z0 output impedance with R0 again infinite. Voltage gain again R0 infinite. And E part, repeat the parts C and D, including the value of R0 is given as 50 kilo ohm. So when we see this diagram, what are the clues given in the diagram? Say for example, you have a fixed resistor RB, right? So it's a fixed bias. Fixed bias, what type of configuration? Because the emitter is grounded, so it is CE configuration. CE configuration, and you know that from the problem it is an RE model. Okay, so RE model. So step 1, let us start with step 1. Let us start with the RE model of fixed bias CE configuration. Okay, so if I draw the RE equivalent model, so I am going to replace this transistor by your RE model. So how it will be replaced? So input is going to be your base. Across the input you will be having beta into RE, the input impedance effect, and across the output you will be having beta into IB along with your resistance R0, right? So this will be your, so this is your collector, and emitter will be grounded. Emitter will be grounded. Okay, so this is going to be a transistor which is replaced by your RE model. Okay, now to the network, what do you have? To the input side, across the base you have your resistor RB. So across your input you have your resistor RB. Okay, across your output you have your resistor RC. Okay, so your input will be your V0, your output is your V0, your input is your Vi. Looking towards the circuit, looking into the circuit, it will be your input impedance Zi. From the output looking towards the circuit will be your output impedance Z0. Okay, so these are the different parameters of your RE model of your fixed bias C configuration. Okay, so step 2, and you know that in step 1, what are the values, general values? Beta will be equal to 50 to 200, and you will be having beta RE will be equal to, either it will be few hundreds of ohms to a maximum of 6K to 7 kilo ohm. Okay, and now what will be the value for R0? Can go from 40 kilo ohm to 50 kilo ohm. That is the reason why they have taken R0 is equal to 50 kilo ohm. Okay, so in step 2 you have to find out, let us find out the first case, that is, you, in order to find out the value for RE, so you have to go through the basics. Okay, so let me consider the input CE configuration. Okay, input is your base, output is your collector, and your emitter is grounded. Okay, so if I convert this into its equivalent circuit, then output side can be converted into your current source beta into IB. So because you know that IC is equal to beta into IB, and across the emitter you can it is replaced by a diode, is replaced by a resistance, equivalent resistance RE, and input is going to be your base. Okay, now this RE is given by 26 millivolt divided by your current IE, because your current which is flowing here is your across the emitter, so it will be your current IE, and this is nothing but the DC equivalent I capital, DC current, not the AC current, because you know that the diode equation RD is equal to 26 millivolt divided by ID. Now this is reconfigured into your resistor RE because it is towards the emitter. So what is this 26 millivolt? It is equal to VT. At room temperature, what is your thermal voltage, and your diode current ID is replaced by means of IE. So this is how you get the equation of RE is equal to 26 millivolt divided by IE. Hope so now your formulas are, you have an idea of the formula. Now let us go on to the problem. So first let us take the A part. A part, you have to find out the value for RE. So you know the formula RE is equal to 26 millivolt divided by IE. So you know that IE is nothing but the DC emitter current, right? DC emitter current. So you have to go forward with the DC analysis of the circuit. So in the case when you do the DC analysis, you know the formulas. IB is equal to, what will be your formula? VCC minus VBE divided by RB. Okay, so what is your VCC given? VCC is equal to 12 volt minus 0.7 divided by what is your RB? 470 kilo ohm. So IB is equal to approximately equal to 24.04 microampere. Okay, so you have got IB. Now what is the relationship between IE and IB? You know that IE is equal to beta plus 1 into IB. What is the value for beta? Given is 100, right? So 100 plus 1, it will be 101 into IB is equal to 24.04 microampere. So IE will be approximately equal to 2.428 milliampere. Okay, now you have got the value for IE. Now can we substitute in the formula? RE is equal to 26 millivolt divided by IE, which is equal to 26 millivolt divided by 2.428 milliampere. So which will be approximately equal to 10.71 ohm. So now you have got the value for RE is equal to 10.71 ohm. Okay, so now you have got the value for RE. Now what can we go to the next part, that is your B part. B part is equal to what you have to find out. You have to find out the value for input impedance, right? So what is your input impedance formula for your RE model? So you know that input impedance formula is equal to RB parallel to the previous slide. You can see that across the input, right, across the input RE model, you will be having RB as well as beta into RE, right, looking towards the input impedance, right, towards the circuit. So RB parallel to beta into RE. So now first you have to find out the value for beta RE. So what is your beta given? Beta is equal to 100. 100 into RE, already you have calculated 10.71. So you will be getting it as 1.071 kilo ohm beta RE. Okay, now Zi will be equal to RB. What is the value for RB? RB is equal to 470 kilo ohm parallel to 1.071 kilo ohm. See, by seeing the equation itself, we know that there is an assumption if beta RE. So if you have a condition, right, if RB is greater than 10 times of beta into RE, so RB is, if RB is very high, then what you will be doing, you will neglect the value for RB and you will be taking the value of beta RE. So instead of doing the calculation directly, you can write the value as Zi will be approximately equal to 1.07 kilo ohm. So why do you neglect this higher value? Because it is a parallel combination. That's the reason. So you can just, if you're not clear with this, you can just do the calculation. Parallel, that is 470 kilo ohm into 1.071 kilo ohm divided by 470 kilo ohm plus 1.071 kilo ohm. So if you solve this also, you will be approximately getting it, the input impedance to be 1.07 kilo ohm. Okay, so for the exam you can write it directly because you can save the time. Now C part is you have to find out what is your output impedance. So you know that output impedance is equal to RC parallel to across the output. What you will be getting? You will be getting, yeah, uh, across the output you will be getting your resistance R0 and your RC, right? So RC parallel to R0. Now R0 is very infinite. It is given. If it is infinite, you will be neglecting the value for R0, and Z0 will be approximately equal to RC. So what is the value for RC? You can write it directly, which is equal to 3 kilo. Okay. Now the next one is D part. D part, what is the value? You have to find out the value for gain. Gain, again you have to, what's the value for your gain? Minus RC parallel to R0 divided by small re. So what will be your value? Minus, so here R0 is considered as infinite, right? So you can neglect R0. So minus RC is equal to 3 kilo ohm divided by RE is equal to, you have already calculated RE, what is the value? 10.71 ohm, right? 10.71 ohm. So you will be getting the value as, what is the value you will be getting approximately, which will be equal to 280.11 gain. Gain doesn't have, it doesn't have a unit. Okay, now what is your E part? E part, you have to calculate the value for C and D, taking into consideration R0 is equal to 50 kilo. So now say for example we are taking Z0 is equal to, what is your value for RC? RC parallel to R0, right? RC is 3 kilo ohm parallel to, now R0 given is equal to 50 kilo. So you can solve it, 3k into 50k divided by 3k plus 50k. So you will be getting Z0 will be approximately equal to 2.83 kilo. Okay. Now what is your AV? AV will be equal to, again, minus RC parallel to R0 divided by RE. So already you have found out the value for what is RC parallel to R0, right? So 2.83 kilo ohm divided by, what is your RE? 10.71 ohm. 71 ohm. So approximately it will be equal to minus 264.24. Okay. So if I can write this value, if I can compare the values, let me take Z0 and AV without R0 and with R0. With R0. So what will be your value with R0 and without R0? Say for example, your output impedance Z0 is equal to 3 kilo ohm without R0, whereas your Z0 is equal to 2.83 kilo ohm. Similarly, AV is equal to, without R0, what is your value? Without R0, you have got 280.11, and with R0, what is the value you have got? Sorry, it's minus, right? With R0, you have got minus 264.24. Okay, so these are the different values of your problem. We have got RE is equal to 10.71 ohm. Then you have input impedance, taking into consideration R0 as infinite, you have got 1.07 kilo ohm. Third, C part, you have got Z0 is equal to 3 kilo ohm. D part, you have got minus 280.11. E part, you are including the value for R0, you have got it as Z0 is equal to 2.83 kilo ohm and AV is equal to minus 264.24.